Now, if you thought that was wild, this next story will absolutely blow your mind. It starts like so many others do with an uneventful stretch of time. In this case, 2 weeks. Then suddenly, catastrophe strikes. You've probably seen these images before, the aftermath of a hurricane ravaging a coastal city. But did you know that it doesn't have to start this way? Sometimes these storms begin not as ferocious whirlwinds, but as tiny waves. Like imagine you're out in the ocean enjoying some downtime. Suddenly you feel a slight bump as you're hit by a minuscule wave. It's barely noticeable. But if you had the right equipment, you could actually detect a miniature tornado inside this small wave, spinning wildly, though too small to cause any real damage. But then, over the course of the next 2 weeks, something incredible happens. This initial miniature tornado expands from a few centimeters to over 100 meters across, slowly gaining power and turning into a beast capable of causing widespread destruction. So, how does such a tiny insignificant event turn into an imminent catastrophe? Let's dive into the science of how a calm sea can turn into a raging storm. So, picture this, you're hanging out at the beach on a nice day, soaking up those rays. Suddenly you get smacked by a small wave. What you didn't notice is that this seemingly random occurrence is the result of a natural phenomenon called a vortex street. Have you ever played the classic game of blowing across the top of a container full of rice to make the grains dance? Vortex streets form in much the same way. As the wind flows past an obstacle, it disturbs the water, creating ripples that resemble the movement of a guitar string. These ripples interact, merging and splitting until they form tiny rotating vortices. So, when you're hit by that small wave, chances are you're riding the outer band of one of these little whirlpools. But don't worry, we're not talking about anything too intense here. We're just dealing with vortices the size of centimeters, moving at speeds less than half a meter per second. But here's where things get interesting. While individual vortices might come and go, under certain conditions, they can spawn a long-lived vortex street. This is similar to how a mother vortex can generate smaller child vortices, which in this case stick together and continue the rotation. But let me ask you a question. If these vortices are so tiny, moving so slowly and only lasting a couple of seconds, how do they manage to survive for days, let alone weeks, eventually growing to hundreds of meters in diameter? To understand this, let's consider another phenomenon known as wave breaking. You see, oceans aren't just flat surfaces. They're constantly in motion. There is a continuous exchange of energy occurring due to wind, Earth's rotation, and even gravitational pulls from the moon and sun. These forces combine to create waves that roll across the ocean surface. And when these waves hit the coast, they often break, transferring their energy into the water column and mixing things up. Now, as our tiny vortex street moves away from the coast, it encounters these broken waves. A lucky vortex can latch onto the crest of a wave and use its upward momentum to boost itself higher. Once lifted above the wave's trough, it gains speed and angular momentum, allowing it to merge with other surviving vortices, forming a larger and stronger vortex. This process is similar to how snowballs grow as they roll, gathering more snow and increasing in size. With enough energy from wave breaking, these combined vortices can survive for days, fueled by the constant supply of energy from the ongoing wave activity. However, there's still one crucial thing missing, namely the fuel needed to grow from a harmless disturbance to a destructive force. Picture this, our growing vortex is cruising along, picking up speed and getting stronger, but it's still not dangerous. That is until it hits a patch of warm water. You see, the ocean isn't uniformly cold. In fact, there are areas where the water temperature can soar up to 30 degrees Celsius. And believe it or not, this heat is what gives hurricanes their destructive power. Here's how it works. As our vortex approaches warm water, it sucks up warm water vapor from the ocean surface. This vapor cools as it rises, forming clouds and releasing even more vapor, creating a cycle that strengthens the vortex. This process is similar to how water evaporates off a puddle, cools in the air, forms clouds, and returns as rain, making the puddle bigger. But instead of a puddle, we're talking about a massive churning vortex of awfulness. As the vortex grows, it sucks up more vapor from the ocean, becoming stronger and expanding. But why does it spin? Well, Earth's rotation plays a role. Thanks to something called the Coriolis effect, moving objects like our vortex are deflected to the right in the northern hemisphere. This deflection causes the vortex to take on a cyclonic spin. As it continues to grow, the vortex sucks up more energy from the warm water vapor, leading to catastrophic consequences. But wait, let's pull the brakes on this vortex train for a minute. This whole scenario sounds pretty straightforward, right? Tiny waves, growing vortices, warm water vapor, boom. Disaster. Well, not so fast. Here's the thing. Scientists haven't actually observed this process in action. They've studied each step individually, but seeing the entire thing play out in real life is still a mystery. Now, don't get me wrong. Scientists have developed computer models that simulate the birth of a hurricane from a tiny vortex. But models are just that, simulations based on our understanding of physics. Seeing it happen for real would provide invaluable insights into this complex phenomenon. Scientists are actively working on tracking the life cycle of ocean vortices and observing how they interact with waves. They're also studying how these vortices evolve as they move across the ocean, incorporating factors like wind speed, wave height, and ocean temperatures. In fact, one team of researchers has made a significant breakthrough in understanding this process. They created a mathematical model that predicts how these tiny vortices grow, accounting for factors like viscosity, surface tension, and the vortex's initial conditions. Their findings were published in the journal Physical Review Fluids in 2022, providing a deeper understanding of the early stages of vortex development. But there's still a lot that remains unknown. We don't yet have the observational data to verify these models. It's like trying to solve a puzzle without all the pieces. We have some of the image on the box to guide us, but we're missing some crucial details. However, we do have observations of individual parts of this puzzle. Scientists have seen solitary eddies detach from the coast, witnessed vortex streets generated by wave breaking, and observed vortices gaining strength by feeding on warm water vapor. But putting it all together, understanding the sequence of events that transforms a tiny vortex into a monstrous hurricane, well, that's still a work in progress. So I hope you enjoyed learning about the amazing science behind how a calm sea can turn into a raging storm. But if you want to dive even deeper into this fascinating topic, check out the video. I put together an overview of recent research into this topic that I highly recommend. And remember, knowledge is power. The more we understand about the world around us, the better equipped we are to face whatever challenges may come our way. So keep learning, stay curious, and who knows, you might just discover something amazing.